Hello everyone, my name is Erik Lamprecht. I'm a mechatronics student at the Hamburg University of Technology, and I will present the wrist rehabilitation game with haptic feedback that was developed at the Institute for Mechatronics in Mechanics. After a short introduction, I will talk about the used system, the medical exercise we want to train with it, and after that the gameplay, the menu and the data we used, and the forearm support stand we created. So the problem we want to solve here is that after a stroke or a wrist injury, the activities of daily living have to be regained by the patient with physical therapy. This process of physical therapy has a slow progress rate, requires the constant presence of a physiotherapist, and needs a lot of time. As a result, it is very cost intensive. By that, the patient can become frustrated or even depressed and disengage with the therapy prematurely. Out of that, there arises a need for a system that enables the patient to conduct therapy independently. The solution for that problem is a video game that's played with a haptic robot to train therapeutic exercises. The benefits of such a system are that the patient can train independently of a therapist, which eases the strain on the overburdened medical sector and also allows the patient to regain some control back of the progress of the therapy, which has an overall positive psychological impact. Also, the system utilizes known motivational effects of video games. The goal of this system are for the patient to invest more time into the therapy and to stay engaged longer. The system we used is the TouchX haptic desktop robot. It's an off-the-shelf system that's usually used for 3D modeling, surgical training, or virtual assembly. This robot can be controlled by the hand of the user and allows for input with 6 degrees of freedom and can apply haptic feedback with 3 degrees of freedom. For the software, we used the Unity game engine together with a plugin and a device driver to allow for communication between the robot and the computer. So after the analysis of the current process of the therapy, we decided to focus on 3 different movement exercises. First, there's supination and pronation, which is the rotation of the wrist around the axis of the forearm. And then there's ulnar and radial deviation, as well as extension and flexion, which are the 2 basic wrist rotations that are possible. The game we use to train these exercises is the game you can see here on the screen. It's a driving simulation where the patient controls a car on a multi-lane highway. The car constantly drives forward, but the patient can induce a lane change by rotating the hand from the neutral position to an angle threshold. The goal is to prevent a collision and to keep the car on the road until the time runs out. Here you can see 3 pictures. Each picture displays the angle thresholds to the left and the right for the 3 movement exercises, as well as the neutral position in the middle. So a movement of the hand between these 3 positions leads to a lane change in the game. And to give a better example for that, here's a short clip of gameplay. You can see that the car is driving down the road, and by the rotation of the hand, an input is made into the game, and the car changes the lane. Before the game itself starts, there's a menu and setup phase. One of our requirements was that the whole game and the whole system can be set up with just very limited knowledge of computers, so it can be played by everyone. For that, it was very important to include the setup phase as a menu inside the game, so that there have to be no further inputs made. The first menu point is to choose the game mode, which is just basically that you can choose which medical exercise you want to train. Then there is the option to select some level parameters. These level parameters are the way to change the difficulty of the game and also the difficulty of the trained movements. And furthermore, there's the option to set a neutral position. The neutral position is the starting point for each medical exercise. To set this neutral position for each patient individually has some advantages. Firstly, it feels much more natural because every person has their own neutral position, so their own natural hand position, and also it decouples the position of the robot from the position of the player, which is also very useful. I've just talked about the level parameters, which is the way to change the difficulty of each level individually, which is very important because the game and the difficulty of the game can adjust it to the progress of the patient inside the therapy. So the first level parameter is the number of lanes, which is a very easy way to change the difficulty of the gameplay. Number 2 to 4 are the angles to the left, the angle to the right, and the angle around the 0 degrees neutral position. So with these values, the size of the hand rotation can be adjusted, which corresponds to the freedom of movement that the patient currently has. So with these three positions, the difficulty of the movement exercise can be adjusted to the progress of the patient. With number 5 and 6, which is the speed of the car and the distance between the obstacles on the road, the difficulty of the game can be changed, and also the reaction time that the patient has to react on this situation and to make an input can be adjusted. At last, number 7 is the time until a level is finished, which corresponds to the endurance that the patient has when playing the game, because that's the time, in that time the patient constantly has to make some inputs to finish the level successfully. Next to the inputs, the robot also gives some haptic feedback to allow for the biggest flexibility and the biggest usability throughout the therapy. Different feedback modes are necessary, and also the parameters for the haptic feedback have to be freely adjustable for each level. Firstly, there's the option for passive training, which means that the hand of the patient is moved by the robot. This is especially useful in the very important early stages of therapy, where the patient has very limited strength in the hand, very limited control in the hand, And so it's here very important that the robot moves the hand of the patient to relearn and retrain these movements. Next, there's active training, which just means that the patient moves the robot with no force feedback involved. And for very late stages of therapy, there's active training with resistance, where the robot offers some counter force to the movement, which really can train the strength and endurance of the patient in the very late stages of therapy. Furthermore, there are 2 intermediate game modes for an easier transition between that phases. Not only this feedback mode can be changed, but also for each level individually, the amount of force that the robot applies can be freely adjusted, as well as the time delay between the haptic feedback, which enables the patient, for example, to try to make the rotation on his own before the robot then comes in with a force to support that movement. For this level parameters and feedback parameters, there are different ways to input them into the game. As I already said, it's very important to keep this process as easy and as basic as possible. So we have 3 options. There's a quick selection in the menu, where some easy level structures can be made. There's the option to just use the last selected values, and for more complex level structures, where really for each level it gets more difficult, so that the difficulty of the game really adjusts to the progress of the therapy. There's a possibility for some spreadsheet documents which can automatically be read into the game. As you can see here, it's just a very standard spreadsheet format that everybody can use. And for each level, each parameter can be changed individually. Next to the input of data into the game, there's also the important point of data output. We log every movement in the game. This provides the patient with important feedback on the progress, but also the therapy can use this game as a tool to assess the progress and as an aid in the process of the diagnostics. One point I want to talk about here is the user interface. After our initial analysis, one requirement was to give very clear feedback throughout the whole game, since it's incredibly important to avoid frustration over an unclear game mechanic. And so the position of the hand of the patient is constantly displayed in relation to the left and right angle threshold. So the current position in relation to the position that has to be reached to make a lane change, and also the neutral position, which always is the starting point for each movement exercises, which is always in the upright position. It has to be noted here that the angle value for the left or right rotation not necessarily have to be the same, because for some movements, as ulnar and radial deviation, for example, the freedom of movement can be different in each direction. Furthermore, there's also audio feedback, which are motor sounds, indicator sounds, and crash sounds, as well as haptic effects in the form of vibration after a crash. Next to the robot and the software component, a third component was created, which is the forearm support stand. This was necessary since the robot can't directly apply a momentum to the hand. So there was the need for a fixed rotation axis to really restrict the movement to not anything else than the medical exercises. For that, we created a forearm support stand with attachment points for the stylus of the robot. This allows for a better interaction between the patient and the robot, and also makes the stylus of the robot easier to grab. Also, it serves the purpose of giving some physical support to the forearm of the patient while playing with an adjustable size, and restricts the movement of the robot to just the medical sizes, the medical exercise that is trained. So there's also always a safety aspect especially when training with persons that have very limited control of their own hands. So this point really was very important for us. Okay, thank you very much for your time.